All right, in this video we are going to be taking a look at radicals. Radicals and maybe looking at simplifying a few radicals. To begin with, what is a radical and how do you recognize them? First off, a radical is, or one example of a radical is something called a square root. You might have seen that symbol before. We might have used it in relation to right triangles and solving Pythagoras. We'll do that again in this section. But the idea of a square root is that a number is a square root of another if, when you square the first one, you get the second. For example, if I wanted to know if 3 is the square root of 9, then if I square this first one, do I get the second one? Yeah. So 3 is equal to the square root of 9. So this square root symbol is asking you really what number, when you multiply it by itself, gives you that. So let's try a couple. So what number, when you multiply it by itself, gives you 36? Of course, answer 6. 121, 11, 84 is 8 times 8. 169 is 13 times 13. Now, one of the things that they talk about in the textbook is that really, by definition, you can say, well, how about if I take minus 13 and multiply it by minus 13? Well, I would also get a positive 69. But in the textbook, they define these square roots only for positive numbers. So they don't let you do that thing there. So the square root of 169 is 13. Here's a couple different ones that have a minus sign out front. Notice the minus, so it'd be like minus 1 times the square root of 49. So you can figure out what the square root of 49 is first. It's 7. And then multiply it by negative 1. So the answer to this question there, to simplify it, would be a negative 7. Same thing with this one. The answer to this would be negative 1 times the square root of 81. And if the square root of 81 is 9, negative 1 times 9, or negative 9. Now, it turns out there's some special numbers like 81, 169, 10 times 10 is 100, 9 times 9, 81, etc. But sometimes you don't get a number bang on, like the square root of 15. I like to sort of ballpark those ones, and you can do them on your calculator. Just find the square root button and hit 15 and see what it comes out to. But I like to ballpark it. Like, I know the square root of 16 is 4, and the square root of 9 is 3. Therefore, the square root of 15 has to be somewhere in between 4 and 3. And since 15 is closer to 16, I'm putting it closer to 4. So maybe 3.8, 3.85, yeah, something like that. Same thing, square root of 30. Square root of 36 is 6. Square root of 25 is 5. So the square root of 30 has to be somewhere in between there. 5.5 maybe, 5.4-ish, something like that. But you could do your calculator to solve that. So you can take the square root of large numbers, you can take the square root of fractions, any number like that, and maybe make sure that you're good at using your calculator to determine those. Now, square roots are something that are found often in equations, and here's an example of one, but there's lots more. So this one, the speed of the car, that's the rate, is given by the equation, determine the speed, car left a skid marks of length L. And so initially, let's say they left skid marks of 50 feet. I think this formula was in feet, so we'll use it in feet. So if I wanted to figure that out, I'm going to put my 50 in there. So I'll rewrite the formula. And instead of the L, that's the length of the skid, I'm going to replace that with 50. So R is going to be equal to 2 times whatever the square root of 5 times 50 is. That's 250. Notice I don't multiply the 2 by the 5 because the 5 and the 50 are in this symbol, which often is classified as a grouping symbol. Sort of like a fraction, where it means you have to do everything inside there and figure out the square root before you apply it to anything else. Okay, so now I've got 2 times the square root of 250. It's got to be somewhere just over 30. Maybe I should get out a calculator and figure that out. Just a second. Okay, didn't want to do that. Calculator. Calculator. Here's my calculator. All right, so on my calculator, I have to sort of go backwards. So I'm going to go 250 and then hit the square root button. That gives me 15, and then times that by 2. So 31.6, call it. So the speed that the person must have been going is about 31.6, whatever the units are. And you could try that. Like if you try it with 130 or 100, whatever, plug number in and see if you can solve that. Now when we're looking at radicals, we looked at a specific case of a square root, but radicals can come in any kind of roots. Like this one here is a cube root, but you could have a 4 there. You could really have any number you want right in that location there. But that number there is actually called the index of the radical. So if it's a square root, then the index is 2. Although in a square root, often it's not written. Like that's a square root, say, of 16. There's no index written, so we assume it to be 2. It's the base one, but we don't have to write the 2. Okay, so that's the index. And then this thing underneath here, this part here, is known as the radicand. Okay, and then the whole thing together is called the radical. Maybe just try identifying those on these next questions. So what is the radicand? It's the thing underneath. So anything, whatever's underneath the radical, that would be a radicand. The index for all three of these questions is 2 because, and you don't have to write it, but since it's not written, we assume it to be a 2. One little rule that you have to worry about with radicals is that typically, unless we're talking about complex numbers, but typically if we're looking at real numbers, we can't take the square root of a negative number because there's no two numbers, identical numbers, that will multiply to give me a negative number. So for example, if I wanted to figure out what the square root of negative 25 is, you can't do that, but you know, it's 5 times 5, but that's 25, not negative 25. You could put a negative here, that times that is negative 25, but these aren't the same. So that breaks the rule of whether it's a square root or not. You could put two negatives, but then a negative times a negative is a positive 25. So if you see the square root of a negative 25 in terms of real numbers, there's no solution to that. You can't do that. Same thing with this one. You couldn't do. Now, if they had a negative, the square root of a positive number, that we can do. Negative out front of the radical sign is okay, but a negative slipped inside there, bzz, can't do that part. Well, now, in complex numbers, we'll look at how we can deal with that, but in terms of the real numbers, can't do it. Okay, now, in terms of just how you can do it with some x's, here's some interesting questions where if you're taking the square root of b squared, the square root and a square of a number are actually opposite operations. So one cancels the other out. So if I have the square root of b squared, this square root symbol cancels the square, leaving me with just a b. Here we put absolute value just to make sure that we're not putting a negative number in there for b, but basically my answer is b. So in this case here, if I have the square of x and y, and I take the square root of that, this square cancels out that square root. So my answer is simply xy. What would it be there? See what you get. Sure enough, if you put 7w, that's correct. How about this one? Now in this one, if you put xy, that would be incorrect. See if you can determine why. Notice that this question and this question are very similar, but this one's in brackets, so it's saying this whole thing is squared. So I can cancel that and that. But in this case here, only the y is squared, not the x. So I couldn't really use that same kind of principle as I did up here. We'll see in future videos how we could rewrite this as the square root of x times the square root of y squared. And then in this case, the square and the square root cancel, leaving me with the square root of x times by y. So I could simplify this one, but not how I was doing it up here. So you just have to sort of be careful. Here's another couple questions that go along the same way. I have something squared, and I'm taking the square root of that. So the square and the square root cancel. So my answer to this, or the simplification to that, is x minus 11. Now down here you may be dying to take the square root of this x squared, but here I have a whole trinomial, and it's not the whole thing squared. However, this looks a whole lot like one of the last sections we did with factoring, whereas I think I could factor that into x plus 4 and x plus 4. And since both of those are the same, like 4 times 4 is 16, 4 plus 4 is 8, so that's factored correctly. Since both of those are the same, you could rewrite that as the square root of x plus 4 all squared. Now I've got something all squared, and I'm taking the square root, so this square root and the square cancels, leaving me with just x plus 4. Okay, so that's a bit of an introduction to radicals. Like we saw in this slide here, we'll be looking in the next the next sections at different rules and properties that we can use to manipulate square roots or radicals, and also solving equations that involve radicals.